This is Algebra 2. Let's graph piecewise functions. So let's create a piecewise function. Let's call it f of x. So we got f of x here. And it's going to be defined as 4 when x is greater than or equal to 2. And it's going to be defined as 2x plus 1 when x is less than 2. Okay, so a useful way to look at these problems is seeing them as graphing different lines and then looking at what's called the domain restriction next to it, the x is greater than 2 or the x is less than 2, to decide which part of the line should really exist. So first, let's look at y equals 4, the first part. This turns out to be graphed as a horizontal line that goes through y equals 4, which will look a lot like this. This is a horizontal line where every single point on it, if you were to make ordered pairs, the y values would be 4. Now, I actually don't want this line to exist forever. I drew it all over the graph, but I only want it to exist when x is greater than or equal to 2. So, when I look at x is 2, right here, everything's greater than on this side right here, to the right. So I don't want anything on the left. So I'm going to erase everything to the left of 2. So, I end right here. Now, I like to note, because it's greater than or equal to 2, we have to put something to let us know that it actually can equal 2. So we put a closed circle that lets us know, hey, this thing can be 2. We're actually halfway done with this problem already. So let's move on to the next part. The next part is y equals 2x plus 1. So this next piece right here is a line, and it turns out this is in a form called slope-intercept form. Slope-intercept form is useful. It's this y equals mx plus b, you may remember. And in it, it shows what my slope should be, my m, and what my y-intercept should be, my b. So in this case, my slope would be 2, because it's being multiplied by x. You can write it as 2 over 1. And my b, my y-intercept, is 1. So using this information, I can graph this line. So my y-intercept is 1 right here. My slope is 2. That means I rise up 2 and run to the right 1. So rise up 2, run right 1, rise up 2, run right 1, and so far and so far. And I can do it in the other direction too, go down 2, left 2 if I do everything opposite and I'm careful. And I will get something that looks like this. Okay, but again, with this I graphed it all over the place, but I didn't look at the domain restriction. I actually only want this to exist when x is less than 2. So that's everything on this side, on the left side of x equaling 2. So let's erase everything that doesn't fit in there. That's this little section right here. Now, right when x equals 2, I actually don't want to include 2. It did not say x can equal 2, it just said strictly less than. So to do that, I put an open circle, and that notes that I am not including that point. And I forgot to put a little arrow here, which I like to do just to show that for sure that thing's going on forever to avoid any confusion. And there we go. We have graphed a piecewise function.